In the previous video, we learned the derivatives of inverse trig functions. We found some derivatives, and I reminded you of what the inverse trig functions were and where their values for answers should come from. Today, we're going to get into integrals of inverse trig functions, and there are two that are the most useful. The first one being the integral of 1 over 1 minus x squared. It's the inverse sine of x plus c. And it's so similar to the cosine one that you could really pull that negative out and make it sine almost every time, so you will almost always use sine more than you will ever use cosine. And the other one is the second one, which is inverse tangent of x plus c. Let's try some. Can we antiderive right now? Yeah, we can. It is the inverse tangent of x from 1 to radical 3. So we need to do the inverse tangent of x from radical 3. Oh, sorry, not of x. Of radical 3 minus the inverse tangent of 1. Now, where is tangent radical 3? And keep in mind that we have to choose from the first or fourth quadrants for tangent. And you will remember or know that it's pi over 3. Where is tangent 1? Again, from the first or third quadrant. And that's pi over 4. Which means 3 pi over 12 minus 4 pi over 12, sorry, minus 3 pi over 12 equals pi over 12. Now, this one is interesting. It's not quite 1 plus x squared in the denominator, so it's not quite tangent, but let's rewrite it. Let's think about it this way. Now, it looks a little bit more like tangent, because 3y squared is 9y squared. So what we want to do is use the u substitution. And we're going to make u that 3y. So du dy is 3, which means dy is equal to du over 3. We can plug this in, 1 over 1 plus u squared, du over 3. Pull our 1/3 out front. And we find that we have 1/3 inverse tangent of u, only we're not dealing with a u, and always plus c when we're indefinite. We actually need 1/3 inverse tangent of 3y plus c. Next one, similar, let's rewrite it a little bit, because typically our inverse sine has something squared here. So we could really write this as 1 over the square root of 1 minus 2x squared dx, which means our u for u substitution should be 2x. And we really have to integral from 0 to 1/4. 1 over radical 1 minus u squared du over 2. Which means I can pull that 1/2 out and have the integral from 0 to 1/4 of 1 over radical 1 minus u squared du. The antiderivative of 1 over radical 1 minus u squared is inverse sine. Make sure you're keeping your integral sign until you antiderive. So 1/2 sine to the negative 1 of u. U is not really u is really 2x, so we need half of inverse sine of 2x from 0 to 1/4. Or 1/2 sine inverse 2 times 1/4 is 1/2. 0, which is 0. And we'll find that sine is equal to 1/2. Again, first and fourth quadrants. It is equal to 1/2 at pi over 6. And sine is equal to 0 at 0. So, that's 0. 1/2 times pi over 6 is pi over 12. And no, not every other problem will have an answer pi over 12, but it does show up once in a while because some of the angles we know when we do math with them works out to have a common denominator of 12. Some of these you need to be very careful. It looks a lot like inverse sine if we were to anti-derive it now, but we can't because of that 2x on top. So we're clearly going to need some u substitution. Let's make u our inner function. So du dx would be negative 2x. Du over negative 2x would equal dx. And I can plug this in. We've got 2x. We make 1 minus x squared our u, so we're going to put a u. Du over negative 2x. And you'll see with the 2x and the 2x will cancel. I can pull the negative out front. So I really have the negative 1 over radical u du. Well, that's not any of our inverse trig functions. Well, let's rewrite it. 1 over radical u is u to the negative 1/2. Is that something that you know how to derive? Yeah. So, let's anti-derive. Add 1, we get 1/2. Divide by the 1/2, we get 2. So negative 2 u to the 1/2 plus c, which really is negative 2 times the square root of our u, which we used was 1 minus x squared plus c. Flip these over. Try to have this click a little bit before you come to class tomorrow so you're ready to roll. If you have questions, let me know tomorrow at the beginning of class.